My name is Jay Weininger. I'm a community college teacher, math teacher, and I'm here to share with you my efforts to introduce Wolfram Research's products to my colleagues. That required me to become somewhat proficient in the language, and I have examples I want to show you, and also to come up with a definition of computational literacy that will ring true with my colleagues. Thank you. After a computer career spanning customer support, programming, and sales, I joined the faculty at a community college as a math instructor. With 43% of our liberal arts students failing algebra, community colleges need an alternative. I've been there 10 years and I've watched the same process over and over again. Obviously, Wolfram Alpha and Wolfram Language are those alternatives. In order to introduce the potential of the software to my colleagues, I became proficient to the extent that I could demonstrate its impact on students' performance and creativity. I will share the details of my learning process with you. And I'll point out the slides, but it's more of, okay. For each of the 4 discussed areas, being database queries, computational essays, system models, and programming paradigms, I will provide coding examples highlighting their impact on student creativity. The first example, let me get it, right here. You can, is the arrow? You can see the arrow. Okay. The first example concerns a medical question. If dengue fever spread to Florida, how many Floridians would be infected? If you notice, the first query, which I didn't expand, provides the stats on dengue fever. The second query, Wolfram Alpha query, informs us of the Florida's population. And then the third is the percentage of that population that would be infected, which comes out to about 17,400 cases. So that's a straightforward medical example of using the database queries. What did I learn from this? You see the queries are very specific. Each one contributes to the overall results. So you can't get too much into a query. Okay, so Wolfram Language provided a query example based on Van Gogh's artwork, the famous one. Now let's see if I can get to it. Give me a moment. What slide am I on? Whoop, I went too far. Here it is. Based on an analysis of 10 randomly selected Van Gogh's paintings, the query determined that the artist in this color palette used a very limited set of colors. This example, let me go back up, introduced me to entities, the entity being the person Van Gogh and his works. It introduced me to functions specific to the content area, chromaticity, to understand his colors, and notation. If you notice let's see if I can get to it, the percent, this refers back to the previous results. So I kept building and trying to become more comfortable with this environment. Note that this results in an answer, not in the list of articles that you have to read that Google provides. Okay? Now I have to go back up. Give me a moment. I'm going back up. Computational essays, the next component, provide numerous ways for expressing your creativity. This talk utilizes calculations that we'll see as we go along You've already seen query results. You've seen images and document formatting, such as the title of this next slide. The two queries show the range of content accessible to your essays. From a community college perspective, each department has access to its discipline's data. So I learned when I talked to the colleagues to be very specific to their area and not go overboard with the potential in Wolfram language and Wolfram alpha. So that's computational essays. Our liberal arts students need a non-mathematical tool for studying nonlinear complex systems. That tool being agent-based modeling. Fortunately, Wolfram language works seamlessly with OneSense tool, NetLogo from Northwestern. Let me get to it. What are you looking at here? The coding that demonstrates how Wolfram language and NetLogo work together. And by integrating, I mean the model's output will be graphically visualized in Wolfram language, because when I go back home, that's what I'm going to start working on, becoming aware and more proficient with the graphics capability in Wolfram's language. By defining the behaviors and interactions of the agents, independent of higher mathematics, our liberal arts students can study these complex systems, which are among the unsolved problems of the 21st century. So you can see from this talk, I'm interested in working with the liberal arts students who may not be as comfortable mathematically as we'd like, but to give them an environment where they can be creative. Our STEM I'm sorry, if anyone wants to say something as we go along, it's fine. Our STEM students use differential equations in their studies, supported by Wolfram Research's system modeler. Okay. I just have to go down a second. I always lose where the arrow is. It's terrible. Where is it? There it is. I'm pointing, that won't help you. Why can't I do this? Here it is. As shown in these last two paragraphs, NetLogo's models overlap with Wolfram language databases. This ensures a productive synergism. They work together. Here comes the harder part. Since these two programming paradigms, functional and rule-based, provide the calculational aspect of your creativity, they need to be understood. I will explain my learning process for grasping them. Let's see, let me go down. First, right here, I wrote a procedural programming, in other words, with looping and indexing, calculating permutations. It included my first, let me get to it, functional statement identified right here. Why is it functional? If you notice, one of its parameters is another function, so the functions are nested. Second, this notation, /ampersand, applies the toString to every element in my item. So that helped me start to be comfortable with functional statements. But truth in lending, I had to call the support group to get me started. Okay, so let's keep going. Why do I keep losing this? Well, okay, we'll go to the next. Next, I studied a non-trivial implementation of a single random Walker automata developed by Gaylord and Nistate. Nisha date. This is not my coding, this is their coding. Why did I pick it? Good question. I picked it because the code uses the rule-based paradigm with its walk, you can see it, the walk statement. How do rules work? When the left-hand side of the rule, in this case these 5 digits, match the pattern being examined, the right-hand side replaces that expression. Also notice that the rule has many variations of arguments. There's many, you see them, there's many rules. And like functions, can be nested. What does that mean? If you notice the right-hand side of these 4 rules, capital R and D, let's see what that leads to. We have to go up. We go up. Here is the rule that the R and D references, and it applies a random integer between 1 and 4 to the site. But I'm not trying to talk about the automata. I'm trying to talk about the learning process that I worked hard on to become comfortable with the functional and rule-based paradigms. Oh, I have to go down. I need to go to another slide. I'm going to get to another slide. I use the software as my instructor to analyze smaller chunks of the code. So what do I mean by that? Whatever is happening here, you see initial configuration. Well, that is computed. Can I see it? Where is my initial configuration? 1 second. Oh, right here. This map thread function, which is highly nested, computes the initial config. So let's go to slide 10, if I can get there. Whoop, I'm already there. You're right, you can't understand the details of this because I took a month studying this. But you see the converted configuration is computed in another nested function. So I used Wolfram language to help me understand the chunks making up the nested functions. This effort reinforced that the lists are the foundational data types of the Wolfram language, with all other formats, sets of matrices, tables, vectors, derived from them. And it's very important to understand what chunk of the list you're working on. Are you working with the whole list? Are you working with the sublist? Are you working with the elements in the sublist? And that's where the level specs become so important. You have to understand those, and that took a little bit of effort. Where's next? Finally, the last step, if you remember, I wrote a procedural version of the program. And I wanted to end up with a functional version of the program, using the functional paradigm, functional programming paradigm. You won't remember, but the initial exercise had 10 or 12 statements. Now it gets reduced to my step and if dictionary word, Q, etc. So I worked very hard to go from my background as a procedural programmer to using the paradigms that are fundamental to programming in Wolfram's language. So what did I take away from this? Wolfram language supports your creativity with its creative functions. I mean, this is unbelievable from my background as a procedural programmer. This in turn requires you thinking about your coding to match that. For example, my initial effort, you can see the difference, R, comma 1, whatever this means, R, comma 1 and 2, I should have realized that if all manipulates the collection, why couldn't I have the second parameter also manipulate that aspect of the list? I don't know why I didn't see that, but to be fair to the support group, they told me. So I had all 1, all 2, all 3, ridiculous. They said use all, comma, all. So you have to change your thinking. Now maybe you're better off if you never programmed, because then you won't have the wrong instincts for this environment. I'm repeating the point. The functional paradigm works with groups, collections. I'm saying this again, that could be the entire list. That could be the sublist making up the list. That could be the elements in that sublist. That's why those level specs are so important, because it locates your processing on that part of the list that you're trying to manipulate. So I have to go back up. Bear with me. I'm going back up. Oh no, am I going up? Oh, here it is. After this brief overview, what did we overview? We overviewed database queries, computational essays, my interest in modeling, because I want to become better at the graphics capability, and then the programming paradigms. So what I'd like you to do to revisit your school experience. So as you can see right here, I don't mean to read to you, imagine if you could use Wolfram Alpha to answer your own questions about the topic you're studied in school. Imagine creating a computational essay and presenting that to your classmates. Imagine participating in studies of complex systems without feeling mathematically inadequate. Imagine your satisfaction of completing a study structured with functional and rule-based coding. So I worked hard to have those imaginations fulfilled. All these processes contribute to your computational literacy, being your creative efforts with their incremental achievements. You notice I showed you the permutation program starting from procedural and ending up with a very condensed version of it based on the functional paradigm. What I'm trying to emphasize, at least with my colleagues where I teach in Gainesville, Florida, that it's better to talk about student performance and enhancing their creativity than it is to discuss computational literacy. Because then what happens, they immediately step back and say, oh, you're math. Ooh, you want me to program. So it may be better to be very specific to that colleague's domain, start with the database queries, and I'm not going to repeat myself, and build up to the computational aspect of what Wolfram Research offers us. Because I've tried for many years to deal with the issue, and I think, did I say it? Did I skip over it? That we flunk 43% of our students year after year in their algebra courses. Well, as I said, Wolfram Research offers an option, an alternative to that. What's the point of doing that? Okay, so I did that. I'm almost done. I'm not doing badly. What time is it now? Oh, then we're doing well. Good, we'll have questions. Now, this got a little overdone, but before I hope we exchange, because I'm very happy to get your input, I'll end with a syllogism. You can see it, my brilliant syllogism. Tools, why am I reading to you? Tools enhance our creativity. Computational literacy is a supersized tool. Therefore, computational literacy supersizes our creativity. And I think that's the takeaway, and that's the way I think you need to deal with your colleagues at a community college. Don't talk about computational literacy. Now, as an aid to our discussion, which I hope we have exchanged, I'll bring up the summary slide that, but forget about the first part, the database, the computation, the modeling, and the paradigms. So we've just completed 5 months of effort. Your turn.